Okay, so for question one, we're looking at, the answer is, I can get you to shout it out. What is the answer? Shout it out. D. D? Yes, that's correct. In index form, the answer is D. So, of course, we've got a base 3 to the power of 4. So, pretty straightforward. Answer is D. Not going to go through it too much. What about question 2? Can I get a show of hands, those students that are okay with part A? A? Sir? Yes? No? Okay, what about B? Can I get a show of students, those that answered B? That's a fair few of you. Minus 5 to the power of 3 is the correct answer. So the answer is B. Why? Because we've got minus 5 times minus 5 times minus 5, which is, of course, minus 5 to the power of 3. Now, if I was to evaluate that, then that's 5 times 5, which is 25, times 5, which is 125, and it is negative because a negative number times a negative number is a positive. And if I multiply that by a negative number, I'm going to get a negative number. So instantly that rules out this. It rules out, well, this is just garbage because this is a negative number and this negative would mean it would be positive. It's not a positive number and it's not 125. So you can do process of elimination if you like. When I multiply two indices of the same base, we are always adding the powers. So 4 to the power of 8 times 4 to the power of 3 is 4 to the power of 11. Can I get a show of hands who got that correct? That is most of the class, if not all of the class. Well done. 3x cubed in expanded form. A lot of students forget the fact that we've got 3x to the power of 3, which is the same as 3x times itself, 3 times. Now, the only option, what can we do? Instantly, we can rule out quite a few options. We can clearly rule out this, and we can clearly rule out this. Because 3 times 3, or 3 to the power of 3 is 27. 3 times 3 times 3 times 3. But we just asked in expanded form. So which one of these is in expanded form? You can shout it out.
D! Oh, no, C.
C. The answer is C, thank you. All right. All right, next one. First of all, a lot of students struggle with this sort of stuff because they don't know what to do with the numbers. Well, guess what? You've been doing maths since primary school, and 2 times 7 is 14. So which ones can we instantly rule out? D and E. We know that we can rule that out. And x to the power of 7 times x to the power of 3, law 1 says that we add the powers, so it's x to the power of 10. Okay, can I get a show of hands, those students that got that one correct? Okay, did anyone here get that incorrect? You can be honest, it's okay. All right, next one. 3 to the power of 4. Now, which law is this, by the way? Which law is this one? It's law 5, because law 3 was, I believe it's any indice in brackets. If a to the power of m to the power of n is equal to, we multiply the powers. Brackets, why? Because, for example, if I had 2 squared to the power of 3, a number of students sort of think that they can add the powers there, and you can't, because that is 2 times 2 by itself 3 times. So we've got 2 times 2 times 2 times 2, and if I was to do that, I can add these powers. 2 to the power of 1 times 2 to the power of 1 and so on is going to give me what? 2 to the power of 6. The answer is 2 to the power of 6 for that. Well, then what about if I had 3 to the power of 4? 3 to the power of 4 is? Shout it out. What is it? 81. You're allowed to shout it out. So 81. So this is actually law 5, which is really an expansion of law 3. Which basically just states that a over m to the power of n is equal to the numerator to the power of n multiplying those powers over m to the power of n. So the answer is 3 to the power of 4, which is 81. So we can cross out that one. We can cross out that one just to make sure that it is A, B, or C. And y to the power of 8. So the answer is C. Can I get a show of hands? And be honest, show of hands who got that one correct. Can I just get someone? Surely, has anyone got an incorrect answer? Who got it incorrect? Thank you. Joel, what did you do?
I did the 81 y to the power of 6.
Okay, so what Joel did, and that's okay, Joel, you've made that mistake now. You won't make that mistake again. What did you do to the powers, Joel?
Y to the power of 6. I missed one of the 2 by 2.
Yep. He added the powers. Is that correct? You did answer as A. Is that correct?
Yes.
Yes, okay. All right, we've got 2 more to go. I'm going to go back to that and we're going to have a look at what's the rule. Anything to the power of 0 equals what?
1.
1. Absolutely. Now, why is this gone? Okay, it's gone. Anything to the power of 0 is 1. Be careful, though, because that's in the brackets. Let's have a look over here. That means that this to the power of 0 is equal to 1. But what have we got over here? We've got a negative 2 times x to the power of 0. Is that going to be 1? 1 times negative 2 is? Negative 2. So what we've got over here is this is negative 2 and this is 1. Negative 2 plus 1 is equal to? Negative 1. Can I get a show of hands, those students that got that correct? Okay, there's not so many hands, I don't think. What a lot of you probably did is x to the power of 0 is 1 and you probably wouldn't have considered that negative sign. Negative 2 times 1 is negative 2. So we've got negative 2 plus 1 is equal to negative 1. And finally, the answer to the last one is 4 squared over 9 squared, which is 16 over 81. The answer is D. Are we happy to move on? All right, beautiful.
Yes, sir.
All right, I'm going to be really quick with this. Express 160 as a product of prime factors. First of all, a lot of students, this was stuff from 6A, and look, I've given it to you as a practice test. It's probably fair to say you might get something similar. First of all, 160, you could do it a number of ways, but we can say that, I'm just going to say that 160 can be expressed. You could have done it 40 times 4 or whatever, but at the end of the day, you're always going to get the right answer. What we do is we stop there because we've got a prime. Product of prime factors. This is a prime factor, so we stop. We continue. 40 times 2. Look at that. It's a prime factor. All right, now you could go 20 times 2, but I'm not going to do that. I'm going to go what? 8 times 5. Is 5 a prime, ladies and gentlemen? Yes, it is. Fantastic. All right. What about 8? We've got, that is 4 and 2. We've got a prime, so we stop there. And then 2, 4 is 2 by 2. We now have our product of prime factors. Now, is that going to give me 2 marks, though? Drawing a tree. No, we can say that to get your full marks, we have to say that 160 is 2 to the power of 1, 2, 3, 4, 5. Plus, is it? Or times, maybe? Times 5. This answer will get you 2 marks. If you think that drawing a tree will get you 2 marks, you are grossly mistaken. All right. Now, these ones are worth 1 mark each. What does 1 mark mean? It means it will give you the answer if you get the answer correct. If you don't get the answer correct, then you get 0 marks. It's one of those things. When we get to VCE, you don't have half marks. So we're going to, this year, in Year 9 Maths, we're going to not really be awarding too many half marks. So be careful of that. Did you have a question, Alberto?
Does it matter what order the answers in? It's like 5.
No, it doesn't. Doesn't matter what order. Okay. So the answer to this is Law 2. But you might want to write it like this, so it's a bit more obvious. But when we're dividing an indice of the same base, we do what to the powers? We subtract the powers. Awesome. Great. Now, the question is this the answer? Would I give you, if you left it like this, given that it says evaluate, would we give you a mark?
Yes.
No, because what is 2 to the power of 5? It's 32, thank you. All right. No calculator in your test, by the way, so if you might need to work that out on the side. Or maybe know your powers of 2s up to 6.
Would that give you half mark?
Sorry? What's that? Yeah, we might award you half a mark, but I want you to just be aware that when you get into VCE, there's not such thing as a half mark. So if the question says evaluate and you haven't evaluated, then despite the fact that you know what index law 1 is, you haven't evaluated it. So in VCE, if you were asked this question, you would get 0 marks. Does that make sense? Okay, next one, 5 to the power of minus 2 is, well, that's the same as 1 over 5 squared because that's our negative index laws. And 1 over 5 squared, once again, you can't leave it like that because 5 squared is 25. Leave it like that, please. Do not go changing it to decimals. Don't need to.
So if you just put 25, would that be wrong?
25 is incorrect, yes. So you get 0 marks. Okay, negative 3 over here, once again, this to the power of 0 is 1. Anything to the power of 0 is 1. So instantly, inside those brackets, I've got minus 3 times 1. The answer is minus 3. Can I get a show of hands, those students that got that correct? All right, we're looking at about half the class. That's all good, but I think that a lot of you are still struggling with that law. The last thing is, this one, what have I got? 2 indices of the same base. I'm adding the powers. 8 minus 5 is 9 to the power of 3, divided by 9 to the power of 3. Now that works out pretty well because anything divided by itself is what? 1. So the answer is just 1. Yeah. Some of you are probably thinking, surely it couldn't be that easy. But guess what it is? Okay, we're going to continue. We're making great time. We've only got 10 minutes, so I'm going to keep pushing on. All right, this one. First of all, what we're going to do, remember, I told you this, 2 times 8 is 2 times 8. Doesn't matter. But, so 2 times 8, I would like you to write a 16 at the start so you avoid making those mistakes. A cubed times a squared is a to the power of 5 because we're adding the powers. But remember that there's this little 1 here, so it's also b to the power of 6 plus 1 is 7. Can I get a show of hands, students, that got that correct? Oh, I'm seeing a few. Can I get a show of hands, those students that didn't multiply 2 by 8 properly? And okay, there, that's good. It's good that we've got some honesty. All right. Now, question is, this question was worth two marks. We would probably give you a mark. We could give you a mark if you might have got perhaps this correct and maybe added something else. But generally speaking, a lot of the time you either knew how to do it or you wouldn't. So a lot of the time you get 2 marks because there's more steps involved than the previous. So the key step is that we're applying this multiplication here, and we're also applying law 1 twice for 2 different pronumerals. So I guess at the end of the day, how we mark that could vary, but it just sort of means that there's a little bit more work involved. First of all, over here, we're expressing 9a. Now, what do? B to the power of minus 4 can be expressed as 1 over b to the power of 4. So, over here, we can actually split this up if we like. 9a over 1 times b to the power of minus 4 over 1. And we know that 9a over 1 is pretty straightforward, but this simplifies to 1 over b to the power of 4. So our answer is 9a over b to the power of 4. Can I get a show of hands, those students that got that one correct? The question is, why is it over? Because I'm going to show you this. 1 is the same as b to the power of 0. Do you agree with that? Yes. Okay, b to the power of 4. Let's do it. When I divide 2 indices of the same base, what do I do to the powers? I subtract the powers. 0 take 4 is b to the power of negative 4. So can you see here that if I replace that with a 1 over b to the power of 4, I've just proven to you that that is equal to b to the power of minus 4. The important thing to realise is that a negative power on the numerator is the same as a positive power on the denominator, or vice versa. No. No. We've got to go through this, Michael. You can go through this after this video's done, yes? Okay? All right. Quite a few of you are muddling up your negatives and stuff, and we'll discuss that before our test next week. All right. First of all, we've got negative 2 to the power of 4. I want you to be aware of this, and you might want to do this. Is this going to be a positive or a negative result? It's going to be a positive result. Given the fact that we've now worked out that 4 negatives is going to be worth a positive, what does that evaluate to? 16. So negative 2 to the power of 4 is 16. See, now, what law is this? This is law 3 we're applying here. Or actually, it's law 4, effectively, because law 3, 4, and 5 are really just the same thing, except one's for multiplication and one's for division. So c squared to the power of 4 is c to the power of 8, d to the power of 12. We're multiplying the powers. I would probably give you a mark for getting the 16 correct, because that in itself took some working. That would be a method mark. And then, of course, getting each of these correct. So this might have been worth 2 or 3 marks. So at the end of the day, if I stop inking and have a look, what was that question worth?
2 marks.
It was worth 2 marks. Okay, no problem. So 2 marks. This one over here, let's do it. It's b to the power of minus 6 times b to the power of minus 15. Guess what? That is minus 6 plus minus 15 is b to the power of negative 21. Now, what does it say up here? Simplify the following. Express all answers with positive indices. Would you get your 2 marks for giving it like this? No, you get 1 mark. The answer is 1 over b to the power of 21. Can I get a show of hands, those students that got that correct? Not many. So it's probably a fair thing to say that a lot of you have to revise negative indices. Thank you. All right. And really, though, the same things apply. All it is doing is adding, it's using law 3 and then law 2. No, sorry, it's using law 1. And then, of course, it's using negative indices. There's 3 important steps there. And if you make an error along the way, then you're not going to get the answer correct. I've got to push on because we've only got 5 minutes left of class. Tristan, you hold off your question until you don't have a question. Okay. All right. The last one. I'd expect this to be tricky. And if you're not getting this, that's okay. But you know what? At the end of the day, it's just applying the laws, the things that we've learned. And if you make one mistake along the way, it's unlikely you'll get it. All right? But at the same time, let's look at how do I change this symbol over here? What do I do? To change this symbol to a times, what do I have to do to the divisor? I flip the divisor, absolutely. So what we've got is we've got AB to the power of minus 4. Get that on top. This one, so that's the first step I've done. Now, you don't have to follow that order, but I've just done it just to make life a little bit easier. Okay, I've got to push on though because I think we're going to run out of time. Okay, a to the power of minus 2b. All right, now what I need to do is I'm going to work out what's inside the brackets over here. And remember that 5 squared is 25. A to the power of 4 times 2 is 8. B to the power of minus 6. Over a to the power of minus 2b times a to b minus 4. And I'm going to work the brackets out on the right-hand side. 5. Now that 5 stays there. Remember that 5 here is not inside the brackets. So that just stays as a constant. So what we've got is a to the power of, what's minus 1 times minus 3, ladies and gentlemen? 3. Positive 3. B to the negative 3. All right, just quickly, I want to finish this off so we can have the whole thing in. What are we doing then? Well, first of all, girls, 25 divided by 5 is 5. So let's do that. Let's do some simplifying. Let's carry across law 1, adding and subtracting indices. Let's do that. A to the power of 8 times A is A to the power of 9, B to the power of minus 10. And let's do the same thing to the bottom. A to the power of minus 2. I'm doing this one here, is A to the power of 1. B to the power of 1 minus 3 is minus 2. Now let's go ahead and apply law 2. A to the power of 9 over A to the power of 1 is 5A to the power of 8. Remember that 5 stays where it does. I don't want you ever moving that 5. Minus 10 minus minus 2 is we're adding 2 to negative 10, which is B to the power of minus 8. Is this the answer though? No, because we want positive indices. So the answer is, 5A to the power of 8. That 5 never goes anywhere because that's what a lot of students do. They move the 5, don't move the 5. There you go. How else could I write that? That's actually the same as 5 times A over B, if you like, to the power of 8. It is quite simple, isn't it, Pete? All right, and just quickly, the last question, the extended response. What was the mistake here? Okay, the mistake here, I'm not going to go through it too much, but 4 to the power of 2 is 16. So the error in this working was that he got a 16. He's supposed to get a 16. This was correct. Y to the power of 8 was correct. That was correct. And therefore, 4 divided by 2 is equal to... it's 16 divided by 2 is equal to 8. And 4 minus minus 2 is what? X to the power of? What is it? No, 4, look, 4 minus minus 2. Thank you. Y to the power of 3. So he made 2 mistakes there. That is 8x of 4 minus minus 2 is 6y cubed. So the 2 mistakes made was, first of all, not multiplying the 4 or squaring the 4. And the second one was... x to the power of 4 divided by x to the power of minus 2 is equal to x to the power of 4 minus negative 2. If you like, I could actually erase that and I could do something. What could I do to this expression to simplify it? Couldn't I get it on the top? How do I get it on the top? I switch this x to the minus 2 and put it on the numerator. X to the power of 4. You can do this as well, ladies and gentlemen. Oh, guess what? That is x to the power of 6. Are there any questions?
No, sir.
All right, well, I'm going to stop this video just in time for the bells. Oh, look at that.